You know, the idea of hopping through time, visiting the past, jumping into the future, it's something that has fascinated us forever. But is it all just science fiction, or does real science actually have something to say about it? Well, let's dive in and explore the really mind-bending science of time travel.
Look, we're all traveling through time. Every single second of every day, we're moving forward. But the real question, the one that changes everything, is, can we control it? Can we actually hit fast forward, rewind, or even just pause? That's the big mystery.
For most of us, our gut feeling is that time is, well, it's fixed. It's like a universal clock that just ticks away at the same speed for absolutely everyone. But then Albert Einstein came along and completely shattered that idea. He showed us that time is actually flexible, it's relative. The speed at which it passes literally depends on how fast you're moving and how much gravity you're in. And that one shift in thinking right there is what opens the door to time travel as a real scientific conversation.
And the person we have to thank for this incredible shift was, of course, Albert Einstein. His theory of relativity wasn't just some abstract concept, it completely rewrote the rulebook for the universe. What he proved is that space and time are actually woven together into this single fabric called space-time. And this fabric can be stretched, it can be warped. And if you can warp space-time, well, you can warp time itself.
Okay, so let's start with traveling forward in time. And here's the absolute kicker. This isn't science fiction. Traveling into the future is scientifically real. It's a proven fact.
The secret sauce that makes this possible is something called time dilation. It's a core piece of Einstein's theory. And put simply, it just means the faster you move through space, the slower you move through time, at least compared to someone who's standing still. And get this isn't just a theory, it is a confirmed, measurable effect.
So, how would you actually do it? Well, picture this. You hop on a spacecraft that can travel insanely fast. I mean, almost the speed of light. As you're zipping through the cosmos, time for you would slow to a crawl. For example, if you took a trip for what felt like 5 years to you, at 99.9% the speed of light, you'd return to an Earth where over a century has passed. You would have literally jumped forward in time.
And this isn't just some fun thought experiment. We see proof of this all the time, just on a much smaller scale. Astronauts on the International Space Station are actually aging just a tiny bit slower than us down here on Earth. The GPS in your phone has to constantly correct its clock for time dilation, otherwise it will be useless in days. And if you were near a black hole where gravity is immense, this effect would be off the charts. Time would practically grind to a halt.
All right, so traveling to the future? It's on the table. But what about the holy grail of time travel? Going back to the past. Yeah, this is where the science gets way trickier. We're moving out of proven facts and into the realm of pure theory.
So, the most popular idea for how to travel backward is the wormhole. The easiest way to think about it is to imagine space-time as a big sheet of paper. To get from one side to the other, you'd usually have to travel all the way across. But a wormhole is like folding the paper over and punching a hole straight through it. It's a tunnel, a shortcut, that connects two different points in space and time.
It's a really cool idea, right? But the problems are huge. I mean, huge. First off, they're completely theoretical. We've never actually seen one. Second, to keep one open, you'd probably need something called exotic matter, which is this hypothetical stuff with weird properties like negative mass that we've never found. And even if you solved all that, they'd probably be so unstable they would collapse the instant you tried to use one. So yeah, we're not building one of these anytime soon.
But okay, let's just pretend for a second. Let's say we solve all those problems. We build a perfect, stable wormhole. We're still not out of the woods, because now we have to face an even bigger hurdle, the logical contradictions, the paradoxes.
This is the one question that keeps physicists and philosophers up at night. If you could go back, could you actually change things? And if you did, what would happen to the present that you left behind?
And this brings us to the most famous mind-bender of them all, the grandfather paradox. Just follow the logic here. Step 1, you travel back in time. Step 2, you do something to prevent your grandparents from ever meeting. Step 3, because of that, you are never born. Okay, but if you were never born, who went back in time in the first place? You see? The whole thing just creates a loop that breaks logic itself.
So how on earth do we get around this? Well, physicists have a couple of really wild potential solutions. One is the parallel universes theory. This says that when you go back and change the past, you don't actually change your past. You just create a brand new branching timeline, a whole different universe. Your original timeline is totally fine. The other idea is the self-consistency principle. This one is more fatalistic. It basically says the laws of physics themselves would stop you from creating a paradox. You can't change the past. Something would always happen to make sure history plays out exactly the way it was supposed to.
Now, with all these insane challenges, you might be thinking, okay, what's the point? Why are we even talking about this if we're probably never going to build a time machine? And that's a fair question.
So let's just do a quick recap of where things stand. Traveling forward into the future? Yep, scientifically confirmed. Traveling backward into the past? Well, that's still a giant question mark. It's theoretically interesting, but man, the practical and logical hurdles are just massive.
But here's the thing. It's the pursuit itself that's so important. Pushing these extreme ideas forces us to test the very limits of what we know. It gives us a much deeper understanding of the universe, of things like gravity, quantum mechanics, and the nature of reality itself. It's all about pushing the boundaries of human knowledge and asking the biggest questions we can imagine.
So where does all this leave us? I think this quote really captures it perfectly. The past may be locked, or perhaps just waiting for the right key. You know, while we might never build a real-life TARDIS, the journey to understand time is one of the most profound adventures in all of science. It tells us less about where we might go and a whole lot more about where we are right now in this giant, mysterious cosmos.